Okay, let's move on to frequency division multiplexing. So frequency division multiplexing is used to multiplex continuous time signals. So basically at a time you can transmit more number of signals rather than only transmitting one. Okay, because your channel bandwidth will be very large, and if you will send only one signal in that channel, then it is as if like you are not using the channel properly. You can send multiple signals at a time just to cover the whole channel bandwidth. Okay, so that is why we do frequency division multiplexing. At different frequency we send different signals. So let's say you have three signals. So these three signal goes through low pass filter. This may look like something like this. Okay, and this may look like something like this. This may look like something like this. All have same bandwidth. Let's say minus 5k to 5k. This is also minus 5k to 5k. This is also minus 5k to 5k. Okay, this is how low pass filter will work. It will restrict the domain of the message signal. For example, if your low pass filter is having a response from minus 5k to 5k, your signal, you can see they are restricted between minus 5 to 5k. Okay, so low pass filter is used to band limit the given message signal. So that is the use of low pass filter. Now each signal will go through a modulator. Now I've written modulator 1, 2 and 3 because they will modulate the signal with different message with different frequencies, carrier frequencies. Okay, so this will have a carrier frequency FC1, let's say FC2, FC3. So all will be modulated with FC1, FC2 and FC3. Okay, that's how it will go. So it will go to the channel after modulation, and at the receiver side, this is the transmitter. At the receiver side, you capture each one of them. So band pass filter is used corresponding to the frequency with which they have been modulated. So if FC1 was the carrier frequency in modulator 1, then band pass filter will have a center frequency FC1 and plus 5, minus 5, FC plus 5, FC minus 5. That's how it will capture message 1. Similarly, it will capture message 2, then message 3. Okay, so that is the role of band pass filter. It will capture first message signal, second message signal, third message signal. Then you apply the demodulator for first, second and third, and you will receive your original message signal back. Okay, so the point is you will send multiple signals in a channel rather than sending only one. Okay, now let's see how the signal will look like. So in the channel, this is how the signal will look like. You have M1, M2, M3 message signal. They are modulated at different carrier frequencies, FC1, FC2, FC3, and the bandwidth is, you can say, 10 Hz, 10 kilohertz, 10 kilohertz, 10 kilohertz. Okay, now there is something called guard band. Okay, which used to keep the two signals apart so that there won't be interference and they can be recovered easily. Okay, so that is why we keep guard bands and this is frequency axis. So guard band keeps two messages apart, and usually we keep the value of guard bands equal. Okay, but it can be different also. The point should be, it should separate the two message signal far enough that is no interference will occur and we can easily recover the message signal. If you will not have any guard band, this is how the signal will look like. They are same, but the guard band is reduced to 0. So you can see there is no guard band. In this case, it is difficult to recover the message signal, as well as there are chances of interference because of the noise and all. Okay, so this is how the signal will look like in channel, which is what I represented in this manner. Okay, so just a quick point. In practical case, we use guard band since band pass filters are not ideal, so it will cover the undesired frequencies as well. So that is why guard band can be used to recover our message signal properly. So in practical case we use the guard band, since band pass filters are not ideal for successful multiplexing. Guard band should be maintained between adjacent signals in a spectrum. Okay, now I hope frequency division multiplexing is clear. Let's see an example. Three message signals, each band limited to 5 kHz, are multiplexed using frequency division multiplexing. The guard band is 1 kHz. Find multiplexed bandwidth when modulation scheme use are AM, that is DSB-FC, DSB, that is DSB-SC, and SSB, that is SSB-SC respectively. Okay. So let's look at the solution. You can think of it in this way. So this is your channel, and message 1, 2, 3 are modulated with carrier frequency FC1, FC2, FC3. Now the modulation schemes used are AM, DSB, SC, and SSB, SC. So your channel bandwidth or multiplex bandwidth you have to calculate. This is 1 kHz band gain. Okay, so you can calculate multiplex bandwidth as 2 FM, because AM requires 2 FM bandwidth. Then 2 FM DSB SC also requires 2 FM. This also requires FM. Okay, so FM, because it is SSB SC. So the signal requires FM bandwidth. Now 1K is your guard band, then this 1K is your guard band. So total you will have 2 into 5K, because each is 5K band limited, that is why 10K, 10K, 5K, 1K, 1K. Total it comes out to be 27 kHz. That is the bandwidth, total bandwidth required to send these three signals using frequency division multiplexing. Let's look at another example. It is given that 10 message signals, each band limited to 20 kHz, are multiplexed using frequency division multiplexing. Guard band is 0.5 kHz. Find multiplex bandwidth if the modulation schemes used for each of them are AM, DSB, and SSB. Okay. Let's look at the solution. So you can say in the case of AM, each signal will require 2 FM bandwidth. So 2 FM into 10 message signal plus the guard bands. Now each guard band is 0.5 kHz and 10 message signals will give 9 gaps. Okay, so that is why 9 into 10, 0.5. So 10 into 2 into 20 kHz plus 9 into 0.5, that comes out to be 404.5 kHz. Okay, this will not be 10, because 10 signals will give only 9 gaps, okay, between them. So I hope it is clear. Then second, if you will consider DSB SC, again the similar thing will happen, because it is also requires 2 FM bandwidth each signal. So 10 into 2 FM plus 9 into 0.5. Okay, guard band is 0.5 and 9 gaps. So this is also come out to be 404.5 kHz. Okay, then third case you have SSB. Then you have each signal will require FM bandwidth. So 10 into FM plus 9 into 0.5, that comes out to be 204.5 kHz. Okay, so the only important point is the 10 signals will give 9 gaps. So you can generalize n signal will give n minus 1 gaps. Okay, so accordingly you apply guard band. Okay, so this was it.